Okay, problem number 9. It says list the key features of both graphs below. So we're going to take it one at a time. We're going to do the linear one first, and then we're going to do the quadratic one second. So the linear one is asking for domain and range. And just so you know, these have arrows. That means they keep going forever and ever. So what's the domain? All real numbers, because it's going to go to the left forever and it's going to go to the right forever. So all real numbers. Okay? What about the range on the linear one? We're still using the arrows, and it's going to go down forever and ever and up forever and ever. So that's all real numbers. Okay? What is the x-intercept for the linear function? The x-intercept. Right here, it's at positive 8. So the x-intercept, we're just going to say is 8, 0. How do you know where the number goes and where the 0 goes? If it's called x-intercept, that number goes on the x, and the 0 goes on the other number. If it's called a y-intercept, the number is going to go in place of the y, and the 0 is going to be in the front. So now I'm looking for the y-intercept. Where does the line cross the y-axis? At negative 8. So it's going to be 0, negative 8. Okay? And the slope, rise over run for that line. Here's another point, so we can just use that one. How much do I go up from negative 8 to 6? 2. And how much do I go over from 0 to 2? 2. So 2 divided by 2 equals positive 1. The slope is 1 for that linear function. Okay? Now the quadratic one. So we're using, there's still going to be arrows on this one. It's going to keep going up forever and ever. And it's going to go to the left and to the right forever and ever. So what's the domain? The domain for this one's all real numbers because it's going to go to the left forever and to the right forever. All real numbers. But what about the range? What is the lowest number that it goes to? Negative 6 right here. So negative 6. Does it equal to negative 6? Does it touch negative 6 right here? It's at negative 6, right? That means it touches it. So it has to have a line underneath. Then what's the highest number that it goes up to? Infinity. Don't tell me it's 8 or 10. Okay? This is going to keep going up and up forever and ever. So that's infinity. So I don't need the whole thing. I really don't need this part. So this is the range, and you can flip it. Y greater than or equal to negative 6, because it's going to go up forever and ever, greater than or equal to negative 6. All right, so the x-intercepts for the quadratic, I'm only talking about the quadratic function. What are the x-intercepts? Where does it cross the x-axis? At 4, and this is not a 1. What is this? Negative 1. This is negative 1 because it's on the negative side. So we're going to say that the x-intercepts are negative 1, 0, and 4, 0. What about the y-intercept? Where does it cross the y-axis? Yep, right here at negative 4. So it's going to be 0, negative 4. Does that quadratic have a maximum or a minimum point? That means does it have a highest point or a lowest point? No. It has a minimum. It has a lowest point right here. The vertex is your lowest point. So we're going to say it's a minimum. Oops. And what was the vertex at? Where was that vertex at? Two and negative 6, or let me erase this. It's kind of in between. It's like right here, like 1.1, 1.5 and 6. It's in between 1 and 2, so it's 1.5 and 6. It's easier in decimals because you can actually tap. It's a negative 6. 1.5 comma negative 6. On decimals, you can actually tap the point and it'll give you the point. And the axis of symmetry is the line that goes through the vertex. So if I was to draw a line that cuts it in half, it would go through 1.5. Okay? And it's on the x-axis, so it's x equals 1.5. And here's the trick, okay? Once you find the vertex, you also found the axis of symmetry because it's the x value of the vertex. Alright? So let's compare the two graphs. What do you notice about all the stuff that we answered on the linear function and the quadratic function? What do they have similar? R row numbers on what? On the domain only. So the domain for linear functions and the domain for quadratic functions is always R row numbers. What else? How many times do these two graphs intersect? How many times does the quadratic intersect the linear? One time. Okay? Could it intersect it twice? Could it intersect twice? Like if I was to draw this line somewhere else, could it cross it 2 times? Yeah, if I draw it like this, it's going to cross it 2 times. Can it cross it 3 times? No. Can it cross it 0 times? Yes, if I put it over here and it never touches the quadratic, then that'll work, right? What about, so where did these two graphs intersect? Where did they intersect? At 2, negative 6. Let's write that down and let's go to the next problem. Okay, so real quick, we're going to go back to problem number 3, and we're going to answer one of these questions, like the first question on problem number 2 and the first question on problem number 1. It's asking for the first and the second finite difference. And we did this last time on the first CBA. So I'm going to show you real quick again, just so you know how we do it. If we're talking about finite difference, we're talking about from here to here. How much did it go? So from 0 to 9, how much is it? 9. From 9 to 36, how much is that? From 9 to 36 is 27. You're subtracting 36 minus 9, right? 27. And then from 36 to 81, so now we're doing 81 minus 36. You have a calculator in front of you. It's right here. How much? 45. That's the first finite difference. When you're looking from here to here, from here to here, from here to here, how much did it change? The second finite difference is going from here to here. So what happened from 9 to 27? 18. And from 27 to 45, subtract them on the calculator. $45 minus 27. 18. Okay? So now it's a pattern. That means all of these on the second finite difference should be 18. So if it ever asks you for the second finite difference, you have to find the first one first and then the second one. And so if it's quadratic, this will be the same. Okay? And that's on the test. First question. Okay, so difference. Think of difference. I'm just finding the differences. This is the first difference, and then this is the second difference. Okay? Let's move on to problem number 10. Okay, so we're going to use this graph for the next 1, 2, 3, 4, 5, 6 questions. The first one says list the key attributes for y equals 1/3 x squared. So we're talking about the red one. In your paper it's not red, but in mine it is. So make sure we're looking at the top one, not the bottom one. Or this little tiny one. So the domain for this one, what is it? All real numbers. I told you that if it's a quadratic, domain is going to be all real numbers every single time. Okay? Range. What is the lowest point that it goes to? 0. Less than or equal to y less than, what's the highest number that it goes to? Infinity. So we don't need that part, and we can flip it. So it's y greater than or equal to 0. X-intercepts, how many does it have? 1. What is the x-intercept? 0, 0. And the y-intercept? 0, 0. Does it have a maximum or a minimum? It has a minimum. It's the lowest point, and it's the vertex, right? So what is that vertex again? 0, 0. And what is the axis of symmetry? X equals 0. Okay? So I need you to do the same thing for problem number 11 and problem number 12, and then I'll do problem 13, 14, and 15 with you in the next video. Go.